Hi, I'm John Norman. Structural collapse is one of the most feared occurrences on the fire ground. They are swift, deadly, and can occur with very little warning. Even though collapses that result in firefighter injuries or fatalities aren't a common occurrence, they account for a large percentage of all multi-casualty incidents. These collapses have accounted for some of the largest firefighter death tolls in U.S. history. A stockyard collapse in Chicago in 1910 cost 23 firefighters' lives. The 23rd Street fire in Manhattan in 1966 killed 12 firefighters. Until September 11th, this was the largest loss of life in the history of the New York Fire Department. The worst firefighting disaster in Boston history occurred at the Vendome Hotel in 1972, claiming the lives of 9 firefighters. A fire at a Waldbaum supermarket in Brooklyn in 1978 took 6 firefighters. A Ford dealership in Hackensack, New Jersey collapsed in 1988 and killed 5. And finally, the terrorist attacks on September 11th that led to the collapse of the World Trade Center towers took the lives of 343 firefighters and medics who made the supreme sacrifice trying to help their fellow New Yorkers. This toll will likely continue, if not increase, because of the changes in construction methods. Modern construction methods place a higher value on lightweight, low-cost materials than it does on the lives of the occupants or firefighters when those materials are exposed to fire. As a firefighter or fire officer, you have a responsibility to yourself, your fellow members, and their families to learn to recognize the causes and warning signs of impending collapse. You must also prepare yourself for the time when a collapse occurs, so that you can take the necessary steps to rescue anyone unfortunate enough to be caught in the debris. Collapses can occur for different reasons and in different ways, depending on the class of the building you're dealing with. Learning to recognize the type of building can enable you to predict how it will behave under fire conditions, especially with regard to collapse. Knowing the building class can give you a general idea of how stable a structure will be when exposed to fire. It can also tell you how much time you should devote to interior operations before possible failure of the structure dictates that you withdraw interior forces. There are 5 building classes. From most to least fire resistant, they are: Class 1. Class 1 construction is generally built using some type of skeletal framework, either poured concrete or steel I-beams. Collapse in this building type is usually rather localized. There may be some spalling of ceiling concrete or sagging of I-beams, but the load that is being supported generally remains in place. When Class 1 structures are exposed to heavy fire, they are designed to provide sufficient resistance to collapse to allow time for evacuation and fire control. As the collapses at the World Trade Center have shown, the type of lightweight construction that is so prevalent in the most modern buildings may not provide enough time for a long stair climb, evacuation, and fire control, then a long descent before collapse occurs. There have been other cases of fires in high-rise buildings where the fire totally consumed all the combustibles on the fire floor, but didn't result in collapse. The 1991 fire at One Meridian Plaza in Philadelphia completely burned out 8 floors, and the building structural engineer warned that there was a danger of collapse, so all firefighters were pulled from the building, and the fire burned itself out, but the building didn't collapse. In 2005, a 32-story high-rise in Madrid was totally gutted by a severe fire, yet only localized collapses occurred. That building was built using a reinforced concrete skeleton, as opposed to the lightweight steel skeletons of many other modern high-rises. The next most fire-resistant construction type is Class 4, heavy timber construction. These buildings are generally quite stable due to the size of their load-bearing members, which are generally 12 by 12-inch wooden columns and brick-bearing walls. In most cases, manual firefighting will have long since shifted to exterior operations before there is a danger of collapse. The volume of fire required to burn through those thick structural members will have driven firefighters out of the building and away from the collapse danger zone. There is, however, one exception: buildings that have been the scene of numerous repeated fires, usually old industrial buildings that have been abandoned by their owners. In these cases, what may seem like a minor fire for such a large, well-built structure could be the one that results in a major collapse. Collapses in these buildings are often large-scale ones, with both walls and floors being affected. At advanced fires in this type structure, all apparatus and members should be removed from the collapse zone. This means the entire area for the full length of the frontage to a distance from the wall at least equal to 1.5 times the height of the wall. The third most collapse-resistant building is a standard brick and wood joist, or Class 3 ordinary construction. These buildings are generally more prone to burn through than collapse. The sheathing above burns through long before the floor or roof joists fail. It is unlikely that any firefighters would be working on the falling surface, but they could be working below it, unaware of overhead conditions due to hung ceilings or smoke conditions. One distinct danger in this type of construction is unusually high floor loads, such as you might find in a plumbing supply or appliance warehouse. Another danger comes from concentrated loads, like roof-mounted HVAC systems or signs. These concentrated loads could result in failure of localized areas without any advanced warning. Any member that discovers one of these loads should immediately report it to the incident commander. The IC should then order any interior forces out of the area below the load until the stability of the floor or roof has been assured. The fourth category in order of resistance to collapse is Class 5 wood frame buildings. The standard wood frame building is more likely to burn through, chasing personnel out before it collapses. This statement only applies to standard construction methods, however. Lightweight wood truss construction, even though it meets the technical definition of a Class 5 wood frame, requires its own special category, containing all lightweight and truss construction. Finally, we come to the least fire-resistant class of construction, Class 2, metal or non-combustible. The main reason it is so prone to failure is the large amounts of unprotected steel that are used in its construction. If the steel were protected by some sort of fireproofing, it would be Class 1 construction, and it wouldn't be as likely to fail. Steel's behavior under fire conditions creates several problems that make collapse more likely. First, steel will expand when heated. A 100-foot-long steel I-beam, heated to 1,000 degrees, will expand by 9.5 inches lengthwise. This expansion can push down columns or walls, or punch holes through walls that can aid fire spread. If the steel is further heated to about 1,500 degrees, it will lose its strength and can either twist and sag or drop its load altogether. Any structural members that depend on that falling steel will also fall. That same steel beam, when cooled with a hose stream, will contract back to its original size, but retain its distorted shape. If a steel beam was severely twisted by heat and then cooled with a hose stream, it can shrink enough that the ends of the beams will no longer be resting on their supports, leading to collapse. Collapses tend to occur in similar fashion in similar types of buildings. Those with protected steel or concrete supporting systems will resist total collapse well. These are called frame structures because most of the weight is carried by the frame or skeleton. Collapses that occur in framed buildings are usually very localized. Only the area between two of the supporting members will collapse. Structures that are built so that most of the weight rests on the outer bearing walls are known as unframed structures. The collapse of a bearing wall tends to cause extensive collapse as the floor supports are taken out. The failure of a vertical member, such as a column or wall, is usually more serious than failure of a horizontal member like a beam, since the column is more likely to support other structural members. Structural elements can be ranked when it comes to the effect their failure will have on the structural stability of the rest of the building. The order of importance of these components, from most to least important, is bearing walls, columns, girders that support beams, beams and joists, and finally, floor or roof decking. Structural collapses can occur from a wide variety of causes. Sometimes they happen before we arrive, as in the case of a gas explosion. Other times they can occur during the initial fire attack, or even after knockdown, during overhaul operations. Many times, media accounts will indicate that a collapse occurred with no warning, but that's usually not the case. More often, the IC and firefighters didn't understand the causes of collapse or failed to recognize those conditions that were present. However, if you're aware of the causes and warning signs, You will know when it is time to take action to avoid having your people caught in a building collapse. Any of the following issues can lead to collapse. A structural weakness due to faults in design, shoddy workmanship, or illegal or improper renovations can cause a collapse. As one noted fire service author put it, one of the greatest danger signs to a firefighter is a 40-yard dumpster parked in front of a fire building. At the Vendome Hotel fire in Boston, the removal and failure to adequately replace a bearing wall, coupled with further alterations to another bearing wall, led to the fatal collapse. If there are renovations being done in your area, go and find out what's being done. Try to evaluate what kind of effects these renovations may have during a fire, particularly on a building's structural integrity. If they don't have a building permit, don't hesitate to get code enforcement involved. If they do have a permit, at least you know that an architect or structural engineer has reviewed the design for possible weakness. The next most common cause of collapse is fire damage to wooden structural members. The failure of wooden bowstring trusses alone accounts for dozens of firefighter deaths, including the Hackensack Ford fire in 1988, Waldbaum's in 1978, and Ridgefield Park in 1968. Add to this the number of roof and floor failures due to burn-through, and the tremendous danger becomes obvious. Remember that wooden elements burn through at a rate of about 1 inch for every 45 minutes of open burning time. And if the fire can attack two sides of a joist, that time is cut in half. That means a standard 1.5 inch joist will burn through completely in less than 45 minutes, and will have lost its load carrying capacity long before that. Steel is affected by heat just like wood. Lightweight steel bar joists can lose their strength in as little as 5 to 10 minutes of fire exposure. Steel structural elements present serious risks unless they have substantial protection from fire in the form of fireproof coatings or casings. Steel often sags prior to total failure. If this sag is visible, that may provide you with sufficient warning, but smoke may hide this from firefighters working below. Cast iron is an older structural material that poses some unique difficulties for firefighters. Cast iron is a very brittle material with great compressive strength but very little shear strength, making it unsuitable for use as beams. However, it was once a favorite material for use in columns, as in prefabricated loft buildings built in the late 1800s. Unfortunately, when cast iron is highly heated and then suddenly cooled, as by a hose stream, or when heated on one side and not the other, it could shatter, causing failure of the column or any cast iron bearing walls. Either case would be catastrophic. Explosions of fuels, explosives, or a backdraft can lead to massive structural collapse. Even relatively low-order explosions can cause vast increases of the pressure inside an enclosed area. As little as 1 pound per square inch exerted laterally can topple a brick wall like a house of cards. Any location where flammable materials or explosives are found should precipitate an immediate shift in tactics from offensive to defensive positions. If you suspect there is a potential for backdraft, all firefighters on the scene need to take the proper actions to prevent it. Be sure to vent at the top before entering below. Another possible cause of collapse is the overloading of floors due to the expansion of absorbent materials. Many manufacturing processes require large quantities of materials that readily absorb water. This can cause problems when you're putting thousands of gallons of water into the structure. Materials such as rolled newsprint, baled rags, and baled cotton can absorb runoff water from hose streams operating nearby. When this occurs, it can cause two effects that may cause collapse. The first is the weight that can be absorbed by these materials. Many of these bales weigh more than 1,000 pounds when dry, and they can absorb their own weight or more in water. This added weight can cause a floor to collapse. The second possible effect is swelling. When these rolls or bales absorb water, they tend to swell up. This swelling can push out walls or knock columns out of plumb. Overloading of the floor or roof can occur even in buildings that don't house absorbent materials. In fact, it's even happened at structures without any fire present. The previously mentioned plumbing supply store, with boxes and boxes of cast iron fittings, can be one possible cause of collapse. Accumulated snow is also problematic in areas with colder climates. However, the biggest offender in fire operations is often runoff water from hose streams. A 1,000 gallon per minute master stream adds approximately 8,500 pounds to the building every minute. If you don't see lots of water pouring out the doors, chances are it's staying inside the structure. An accumulation of a single foot of water over a 20 by 20 floor area represents nearly 25,000 pounds added to that load. One factor that we have direct control over is the cutting or removal of structural members during overhaul. You must avoid removing any structural components, unless they obviously are not supporting any weight other than their own. There is rarely any reason to do so anyway. Careless overhauling could result in at least partial collapse around the members. Many times we have to operate in areas that are only marginally stable. Even though you can walk across an area that has been damaged, you must avoid jumping on it or doing anything else that could cause an impact load. If you have to operate in an area where you suspect structural weakness, use methods and tools that won't produce much impact or vibration. For instance, if you have to cut a piece of flooring, use a circular saw instead of an axe or a reciprocating saw. Impact loads and vibration can also come from external sources. Nearby rail lines or highways could cause the collapse of an already shaky structure. High winds, flooding, and damage to water mains can also cause collapse under the right circumstances. Other times, the impact of high-velocity hose streams is enough to knock structural supports out of place entirely or simply displace them enough to allow other factors to come into play. If you're using an elevating platform in an operation, be sure to keep it a safe distance from the structure. They have been known to knock down parapets and roofs just by bumping into them. Then, of course, there's just plain old age. Very few buildings are designed to last more than 100 years. Some of them are way past that milestone and are just looking for a reason to fall down. Keep in mind that gravity is always trying to flatten vertical objects. Our job as firefighters is to make sure that nobody is in the way when they finally do come down. In order to avoid being caught in a collapse, we must constantly examine the structure for indications that it's losing the battle against gravity. These indications could be visible cracks in the walls, audible noises indicating movement, or something less obvious, like a heavily loaded floor. By themselves, each indication might not raise enough alarm to provoke an evacuation, but taken together, they could add up to the warning signs of imminent collapse. Because of this, it is essential that the IC be promptly notified of any of the following indicators of collapse. We know from past experience that certain occupancies present unusually heavy floor loads. Plumbing supply stores, appliance dealerships, and printing shops all have large concentrations of heavy items. Other occupancies, such as supermarkets, car dealerships, bowling alleys, and churches, tend to use truss construction. Although the type of occupancy alone doesn't provide sufficient reason to withdraw all forces, it should get you looking for additional signs of possible collapse. Fires in truss construction and other lightweight buildings will be the fire problem of the 21st century as today's buildings deteriorate. We will have to employ a new style of firefighting to combat fires in these structures. Or maybe it's not so new after all. It involves standing back and lobbing water from outside the collapse zone if the fire seriously involves trusses. Other new styles of lightweight structure, like particle board I-beams, require the same technique. Constantly observe the floor loading to see whether it poses a risk of collapsing to the floor below. Heavy equipment, water-absorbent stock, and built-up water are all prime indicators of potential collapse. You may not be able to tell at a glance the extent of a fire or how long it's been burning, but if you've been fighting heavy fire for 20 minutes and you haven't put it out, you should probably withdraw your forces. When the first members come out of the building with their low air alarms ringing, it's time to make a decision. The reports of interior conditions by that first team should give you an idea of what to do. If they say that most of the fire is knocked down, then it's probably okay to continue operations. However, if they say they haven't put a dent in the fire or haven't even been able to locate the seat, it's time to pull them out. This is a guide rather than a hard and fast rule, and I tend to keep it on the conservative side. Remember that the 20-minute time frame doesn't start when you arrive, or even when you get the alarm, but rather when the fire reaches flashover and begins to attack the structural elements. If you're dealing with lightweight construction, even that 20-minute time frame is too long. In that case, a 5-minute window is more appropriate. That could mean you don't even enter the structure if your response time approaches 3 or 4 minutes. Keep an eye out for runoff. If you've been putting large quantities of water on the fire with multiple hose lines and there's only a trickle coming out the front door, then something is definitely wrong. All that water is collecting somewhere, and you'd better find out where before it brings the floors crashing down on your head. Cracks or bulges in walls are obvious signs of weakness. Unfortunately, you can't always tell if a crack has just formed or if it's been there for 40 years. That being said, you always have to pay attention to cracks that are expanding or lengthening. They are definite indicators of movement and should tell you it's time to get your people out. Smoke or water pushing through a solid brick wall is a sign that pressure has built up on the other side of that wall. It also tells you that there are weaknesses in the wall's construction. Either one of these can cause collapse of that wall. If the roof is pulling away from the wall, you might be able to tell if you can look at the ends of the beams at the wall joints. The ends of beams that were set into the wall may have been pulled partway out of the wall, exposing clean wood at the end. Also, check roofing material at the wall joint. If you find gaps, then the roof may be pulling away from the wall. Visible sagging in the roof or floors is one of the final warning signs you'll see before a collapse. If you see it, promptly pull everyone out of the endangered area and any areas below. Of course, you always have to watch for visible movement of floors, walls, or roofs. Doors that suddenly open or close, or windows that suddenly break for no obvious reason are all signs that the walls they are in is shifting and collapse is imminent. It may be too late to reach safety once these signs are noticed, so be sure to pay attention to the other early warning signs so you don't find yourself surprised when that wall or floor comes crashing down. Plaster sliding off walls or plaster dust hanging in the air could indicate shifting or subtle movement. Plaster is applied over a lath that is held rigidly to the structure, but the plaster itself isn't directly attached. When walls or ceilings shift, the plaster may be wiggled off in fairly large chunks. Any creaking or groaning sounds that you hear in a building could also be indications of movement. You might hear deep rumbling sounds if remote areas of the structure suffer partial collapse. Once you've recognized the possibility of collapse, you must take the necessary steps to remove anyone from its path. Make sure to allow plenty of time for an orderly evacuation. An orderly evacuation means that all members are located, informed, and they're able to bring out all of their equipment, as opposed to an emergency evacuation when it's time to drop your tools and run. The portable radio is the usual means of issuing an evacuation order. Once the IC has issued orders to evacuate, he or she should contact each unit individually and confirm the order was received. If any unit fails to acknowledge, the IC has to send someone in to notify them of the danger of collapse and the need to evacuate. Sometimes, in the noise and confusion of a fire scene, members may miss the radio call, and some members may not be equipped with portable radios. In that case, you need another means of notifying everyone of the evacuation order. One method that I've used in the past is to order all apparatus on the fire ground to turn on all audible warning devices, like sirens and air horns, for a full minute. Any members within the structure that missed the evacuation order should be able to hear that kind of racket and recognize it as the emergency evacuation signal. Whatever system your department uses for evacuation, the signal must be known and heeded by all members for it to be effective. However, simply getting all the members out of the structure may not be enough to ensure their safety. Collapsing walls can fall great distances and project debris even further. What you must do once you've ordered an evacuation is to establish safe exterior collapse zones. Once you've decided to shift to an exterior attack because of potential collapse, there's no reason to have firefighters in close proximity to the building. We have surrendered that building. Back off and use the reach of the hose streams. At one incident, a lieutenant was killed and 2 firefighters were badly injured by a falling wall after they'd been ordered withdrawn from the building. They had then been ordered closer to the structure in order to direct an exterior stream through an open doorway. What makes this loss of life even more aggravating is that the building they were attacking was vacant and had been the site of many previous fires. Don't risk the lives of yourself or your firefighters on a building that isn't worth saving. The size of the collapse zone must be at least 1.5 times the height of the facing wall. If the wall is 30 feet high, then all personnel must be cleared for a distance out from the wall for at least 45 feet. Older trains of thought held that brick walls would crumble as they collapsed. They can, but more often than not, they will lean over at full height. Any collapse zone that is less than 1.5 times the height of the wall is likely to kill any members that are left inside the zone. At times, even a collapse zone that is 1.5 times the height of the wall is still too short. Collapse initiated by an explosion is the obvious instance where this is true. There is one particular type of building, however, that has proved deadly beyond what were once thought of as safe collapse zones. These are buildings with bowstring truss roofs, in which the hip raft is spanned from the end trusses down and out to a bearing wall. We're about halfway there when a ladder company comes on and gives a screaming third alarm and says, "We just had a major collapse. Get us a couple of more rescue companies and a bunch of ambulances. We got a big collapse. We got firemen buried." Now I'm like, uh-oh, we're in big trouble. I don't know what's going on here, but this is not good. So we get down there, help dig these guys out, and they're hurt bad. Broken ribs, one broken femur, punctured lungs, broken collarbone, bad facial burns. They weren't just hit with bricks or bouncing debris. These guys were buried. They were out in a safe location. They were not trying to get into that building. They had pre-planned the building. They knew it was vacant. They knew what they were supposed to do. Nobody was going on the roof. Nobody was going near the building. They were setting up a portable master stream device out what they thought was beyond the collapse zone.